So in this video, let's talk about what is a reference angle. So a reference angle specifically talks about like when you typically draw an angle, we usually call that angle theta. So let's say you drew an angle. Here's the terminal side, right? Well, the reference angle is always the angle that it creates with the terminal side and the horizontal axis, or in this case, the x-axis. So what I'm saying is that this angle right here that it produces is what we call the reference angle, which I'll just refer to as a theta with a little dash on it or apostrophe, so that way you can see the difference between the standard position angle versus the reference angle. So in my mind, the reference angle is like the thing that makes that triangle, or it looks kind of like a triangle to me, where you use the terminal side and the horizontal axis to help you kind of form that triangle, and that's the angle that I'm thinking about. I also want to mention that reference angles are always positive. They are always positive angles. So if I had to figure out what this angle is here, I would take 180, subtract whatever this angle is, and get that angle. But make sure you write it as a positive angle. Whereas this one, this starts the initial side and goes all the way over here. This is the terminal side. So the reference angle here is, pivots with the horizontal side. So if I were to form a triangle, this here would be my reference angle. So between the terminal angle and the horizontal axis. Whereas this one here, notice how it pivots all the way to the fourth quadrant. So my reference angle is going to be from here to here. You can kind of form a triangle like that, or a right triangle. So going into this, we are going to be trying to calculate what is the reference angle if I gave you the standard position angle. So in this case here, if I gave you 300, let's just draw what 300 would look like on a coordinate system. So if I were to draw 300, this goes from 0 to 90 degrees to 180 to 270 and then back to 360. So in this case, the angle, terminal side would be right here and would swing all the way around to about here for 300. So 300 somewhere in the fourth quadrant. In that case, the reference angle needs to be this angle right here. Let me see if I can zoom in just a little bit. Is going to be my reference angle. If I were to draw a triangle, this is the horizontal axis and this is my terminal angle. So I need to figure out what is the angle right here. And to do that, well, if I know this entire angle here is 300, then I could just take 360 and subtract it by 300. So if I were to take 360 degrees, subtract 300, that would give me 60 degrees. So my reference angle is going to be 60 degrees. There we go. All right, this one here is a negative angle, so make sure you figure out where it would land in which quadrant. And we're going to be going in the clockwise direction because it's a negative. So this would be 0, negative 90 degrees, negative 180 degrees. And so it has to land somewhere between negative 90 and negative 180. So somewhere in the third quadrant. So here would be our initial angle, and our terminal angle lands somewhere in the third quadrant. So our reference angle is somewhere right here. So if I were to try to calculate it, I can think about, okay, if this entire line right here is 180, and this piece is taking up 135, I can take 180 and subtract 135. So I'm going to take 180 degrees, subtract 135. So I'm figuring out the math using a visual model. So for me, I have to draw the picture and figure out what I'm subtracting with. Notice that this one I subtract with 360, this one I'm subtracting with 180. It all depends on your picture. So this one, 180 minus 135 is 45 degrees. So my reference angle is 45 degrees. And notice that I've been writing the reference angle in positive angles as positive values, because the reference angles are always asking what is the angle or the distance angle that's between the terminal angle and the horizontal line or the horizontal axis. All right, let's try this in radians. I want you to notice that both of these are actually in radians. This one is 5 pi over 3, which, but with the pi, we know that it's in radians. This does not have a degree sign. So if it does not have a degree sign, it is also in radians. Why? Because, well, if we were not to write the pi for a sec, let's think about pi in general. Pi is a number that goes on and on forever, but it's 3.14. But it goes on and on forever. So sometimes you can write radians as just as a number or decimal form. Not necessarily you have to write it with a pi. So I thought I just, clear up that air. So for this problem here, we have 5 pi over 3. So if we look at the unit circle for a sec, if we go by radians, this is 0, pi over 2, pi, and 3 pi over 2, and then back to 2 pi. So 5 pi over 3, if I were to change everything to a denominator of 3, well, there's nothing here that is, let's see, or I could change the denominator to 6, because some of my denominators here are 2. So let's change it to 6, actually. So if I change the denominator to 6, I have 10 pi over 6. So if I look at this one here, I have a prediction that's somewhere between maybe pi, 3 pi over 2, or 2 pi. So this is 6 pi over 6. This guy is equivalent to, if I multiply by 3 to make the denominator 6, this would be 6, 9 pi. And 2 pi is equivalent to 12 pi over 6. Right, because 12 divided by 6 is 2. So that's how I can try to make all the denominators look the same, is to try to make a common denominator 6, since I have a 3 and the unit circle has denominators of 2. So let's see where 10 pi would go. So 10 pi would be somewhere between 3 pi over 2 and 2 pi, because it's between 9 pi over 6 and 12 pi over 6. So 10 is between 9 and 12. So this is going to be somewhere here for 10 pi over 6. And so that means that, actually, let me change that, not to 10 pi, just as 5, what it was originally. So 5 pi over 3. So when I'm looking at this here, I need to figure out what is the angle here. So what I could do is take a look. This here is 2 pi, and this here is 5 pi over 3. To get to this angle here, 2 pi, if I take 2 pi and subtract by 5 pi over 3, I would just find a common denominator. So put 2 pi over 1. And I could try to make this guy a 3 if I multiply the top and bottom by 3. So this is 6 pi over 3 minus 5 pi over 3. So the denominators are now the same. So what I did was I multiplied the top and bottom by 3 to make a common denominator. So that's why this is 6 pi over 3. Subtract the top. That is going to give me 1 pi over 3. So this angle right here is 1 pi over 3, or pi over 3. Which makes sense. If I were to add 1 pi to this, that would be 6 pi over 3, which would be equivalent to 2 pi. All right, this next one here, this one's kind of weird. So I have 2.3 here, and just as a frame of reference, I know that pi is equivalent to 3.14. So that's what pi symbolizes. So if I were to try to write things, well, if this is 0, this is pi over 2, and this is pi, then I know that pi is equivalent to about 3.4, right? Like sort of close to 3.14. So I know that 2.3 can't pass 3.4. So it's either in this quadrant or this quadrant. So what I'm going to do here is figure out what is pi over 2. What is about 3.4 divided by 2? So if I use my calculator, 3.14 divided by 2 is about 1.5. So this number here is not in the first quadrant because 2.3 is bigger than 1.75, or sorry, 1.57. So it's somewhere in this quadrant then. So here's my initial angle. If I were to go to here, this is about 2.3. And so I need to figure out what is the angle here going to be. So if I were to figure out what this angle is, I could take 3.14, since that is a rounded value of pi. I'll just use the rounded value. And I'll subtract it with 2.3. So I'm taking 3.14 and subtracting it from this angle to figure out what is left over that will go here as my angle. So 3.14 minus 2.3 is 0.84. And that there is the angle in radians that is the reference angle. And this is a rounded value because I didn't use the exact value of pi since it's a number that never stops. So this is a rounded value about 2 decimal places. And that's it. You probably won't get a lot of these problems. It's more likely the first 3 problems you'll see more often. But I thought I'd make that clarification that radians doesn't have to be always written as a pi. It can be written as just a decimal number or just as a whole number. As long as it doesn't have a degree sign, that's how I know it's not a degree. So for the next part here in example 8, it wants you to figure out what sine and cosine tangent of the angle of negative 750 is. So before we can do that, it does have a few steps that they want us to do. And the first part is to find the reference angle, and we don't use a calculator in this case, is what it says in the direction. So if we were to do this without a calculator, let's start by making a picture. I know that helps me. So this is a negative angle, so I'm going to go from 0, negative 90 to negative 180 to negative 270, and then back to negative 360. So I'm going in that clockwise direction. So if my initial angle starts here and I were to go around one time, that's already 360 degrees, and that's not enough. This is negative 750 degrees. So I have to go another, let's see if I can redraw that angle. So I went around one time. I'm going to go around another time. So if I go around an extra lap, so here's my second lap that I'm about to go over, that would be another 360. So 360 plus another 360 is about 720, and that's still not enough. I need about 30 degrees more past the x-axis, so about 30 degrees. And I'd land somewhere here at negative 30 degrees. So because I'm passing it another 30 degrees, this would be negative 30 degrees past the x-axis. So that tells me that this piece right here is, this reference angle is going to be 30 degrees because reference angles are always positive angles. So here's what happened. Let me show you guys the math. I went 350 degrees. I went 360 degrees around, and that gave me to negative 390. Took another 360 degrees from where I left off. So if I add another 360, I get negative 30 degrees. And so I knew that when I passed it, I should hit it around negative 30 degrees. And from here, that is my reference angle, because I have to write it as a positive angle. All right, then we need to find sine, cosine, and tangent. And this is where we need to grab probably the unit circle to help us out. So on the unit circle, let me just draw us a picture so we can kind of visualize it together. So here's our negative 30 degrees. When you look at the unit circle at negative 30 degrees, it's also equivalent to 330 degrees. And that coordinate there is root 3 over 2 and 1/2. In that case, that's my x, that's my y. And so if I want to know what sine is of negative 750 degrees, then that would be my y value. And my y value here is 1/2. Ooh, I think I almost forgot. So in the fourth quadrant, so the y value is a negative 1/2. My bad. cosine is negative 750 degrees is equivalent to the x value, which is root 3 over 2. So I have my y, I have my x for my cosine, I need my tangent. So tangent takes a little bit more work for this angle because you have to put y over x to find tangent. So my y here is the negative 1/2 over my x, which is root 3 over 2. So I have to multiply and flip. Oops. Negative 1/2 flip 2 over root 3. So the 2's cancel, giving me negative 1/2 root 3. I can multiply the bottom and the top by root 3 to make it cancel out the root. So 3 would now be on the bottom, and the top would just be negative 1 times root 3. So that's negative root 3. And that there is my tangent value. And there we go. So that is it for this video here. There are no practice problems for this journal just because I feel like this journal is quite heavy to begin with. So we'll just leave it there. If you want to try out some of the more practice problems, check out the textbook problem at 4.4. So you can find those textbook problems on Canvas or my schedule spreadsheet. And these are the problems I recommend trying out to get some more practice on the skills that we just learned today. All right, guys, bye.